Hey guys, and good morning. So today we are going to be going over geometric sequences. We have two types of formulas to look at today, the recursive, and then this one you just must know the previous term. There's two formulas, but today we're looking at the geometric side. And so the recursive one is basically, I look at it personally just as a way to identify what is given. I personally prefer the explicit formula when using it to find the nth term or the term that the question is asking you to look for. So if I move my little picture out of the way, maybe, nope, I can't move it. Anyways, the bottom one says for a geometric sequence, which is what we're focusing on today. So anytime that you need the particular sequences, you can refer back to this Google Slides presentation. On slide number 5, you will find the recursive and explicit. If you're watching this and you're not in my Math 1 class, here's the explicit formulas for geometric sequences. Moving on to the very next slide, we have patios are us, and then we rock landscaping. So what we figured out was the relationship between my y value. So if this was the x value, and then this was a y value, the relationship that was happening here was we were adding 5 each and every time. So this one right here had a linear relationship. It was increasing by 5. So if you think back to slope, it would be up 5 over 1, up 5 over 1 type of situation, which we know would be y is equal to 5x. Okay? And then the bottom one, or sorry, not the bottom one, but the We Rock landscaping here, you are, if you take 5 plus 5, you get 10, but 10 plus 5 is not 20. 20 plus 5 is not 40. And so the relationship that's happening here is you're multiplying by 2. Multiplying by 2. Multiplying by 2. Multiplying by 2. Okay, so for that one, we have the base is 2. My exponent is x. And then my ratio again there is multiplying by 2. And then my very first term here in this particular problem was the number 5. So I would take 5 times 2 to the x power. Okay, so on the next one, we are now finding, that was the difference between arithmetic or a linear function, geometric or an exponential function. So now we're going to be finding the patterns. And as you can see on these, adding or subtracting is not going to work. So we're moving more on to finding the ratio. And the ratio is just a way to multiply. So how do I go from 5 to 10? I multiply by 2. 10 to 20, I multiply by 2. 20 to 40, I multiply by 2. How do I go from negative 11 to positive 22? This one, I multiply by negative 2. Positive to a negative, multiply by negative 2. Negative to a positive, multiply by negative 2. So the pattern here was multiplying by 2. And then here was multiplying by negative 2. It took me too long to write out the word multiply. Okay, so now the last one looks a little tricky. So let's make sure that whenever we're doing the ratio, we're thinking multiplication and not necessarily division. It's going to throw off the way that you set up your particular formula to find the term that you're looking for. And so to go to 4, I'm going to write this as 4 over 1. So to go to the number 4, or 4 over 1, to 8 over 3, I'm multiplying by the number 2/3. Okay, so sometimes they are going to be represented as fractions, but make sure that we're always looking at it as we're multiplying by a number, not dividing. And let me clear off that on the screen so we can move on to the next one. So let's go back to sequence A. So we have 5, 10, 20, and 40, and now we have our explicit formula. So AN is going to be the term that you are looking for. A1 is the first term. R is your ratio, and then N again is the term that you're looking for. So basically, as I was to write out this particular formula, A1 is your first term. Okay, so I would write down AN is equal to A1 being my first term, which is 5. I'm multiplying in this case because they're exponential. Let me use red. multiply. And I'm going to put the n minus 1 on the outside of the parentheses. And my ratio is what we are multiplying on this particular sequence. And it was sequence A, and we are multiplying by 2. So 2 is the base of that exponent. So 5, first term, times 2 to the n minus 1 power. And that is a particular formula that we are going to be using to find the terms that we're looking for. Today, you're just setting up the formulas. Day 2, we're going to start finding the terms that it's asking you for. And you can also see that this is very, very similar to our exponential function. That was, you had the base for your exponent, and then you had x, and then remember the y-intercept was the a value that was out front. Okay, so y equals a times bx. So it's pretty much the same concept where n minus 1 now would be your x value, which we're going to get into that as we find the nth term here a little bit later. Okay, so now we need to find an equation for each sequence, and we're going to find the term. So we're going to be using the explicit formula only because that is my personal one that I go to find the nth term. It's the easiest one for me. So we have an, which is a term that we're going to be looking for. That is going to equal my first term, which is 1, times my ratio. So what is happening as I go through this sequence? Well, I am multiplying by 1/2. So 1/2 is my ratio. And then I have n minus 1. Now it's asking me to find the 30th term. So that's 1 times 1/2. 30 minus 1. Now, if you're using Desmos.com, which I strongly encourage you to do so because that is the calculator that's going to be active on your test, it's not going to allow us to do the exponent of 30 minus 1, but we know that's 29. So as I put this in my calculator, the first term was 1, right? 1 times 1/2. Okay, so 1 times 1 divided by 2 to represent 1/2. I'm going to click up here so I can close my parentheses, and it's not going to be on the denominator of that fraction. Here's my exponent, and my exponent was 29. Okay, so as you can see, this number looks a little bit different than what we're used to before. Anytime that you see times 10 to an exponent, that's written in what is called scientific notation. So that's going to take us back just a little bit into remembering our exponent laws. So 10 to the negative 9th power is really saying that we're dividing by 10 9 times. So this particular number being 1.86, I'm going to round it there just for the purpose of this video. Saying that it is 10 to the negative 9th power right here means I'm going to be dividing by 10 9 times. So that place value is going to change. And again, dividing is going to take my decimal point to the left 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my number is really, really tiny. And so I'm going to fill in all those decimal place values there with the number 0. And so scientific notation is just a way to express very, very small numbers, or we're going to get to it very, very large numbers later in this video. So you don't have to write out so many zeros. You can just express it as 1.86 times 10 to the negative 9th. So again, it's just representing a very, very small number. And let's go back. So on the very next one here, we are going to be, again, finding the particular pattern that is happening, and it's asking us for the 100th term. So to go from 6 to negative 3, negative 3 to 2/3, like yes, technically we're dividing by 2, but we need to write this as multiplication. And so in this case, we're multiplying by negative 1/2. And I know it was negative because we're going from positive to negative, negative to positive, positive to negative. So again, my equation would be an is equal to my first term being 6. My ratio is negative 1/2, and then n minus 1. And it's asking us to find the 100th term, so that's 6 times negative 1/2 times 100 minus 1, which we know that as 99. So as I go into Desmos.com, we're going to do 6 times negative 1. Nope. 1 divided by 2 click up here so I can close out my parentheses, and my exponent was 99. So as you can see, again, it's written in scientific notation, and it's a negative exponent in the scientific notation, so my number is going to be very, very small. I personally am not going to move the place value 30 times because that's just a lot of extra stuff. But just know that this number has a lot of zeros, and it's very, very small because it's negative 30 power. Okay? And then the very next one is we need to find the 200th term with a sequence here that is given. And so if I'm going from 2 to 6, I'm multiplying by 3, multiplying by 3. So my very first term, so to find my term that it's asking for, I take the first one, which is 2, multiply by my ratio, n minus 1. So it's 2 times 3, and then it's asking us for the 200 term, so I take 200 and I subtract 1 from it, and we know that is 199. So I'm going to clear this off. I'm going to do 2 times 3 raised to the 199th power, and that number is 1.77. Let's just go around it there, times 10 to the 95th power. So there's no negative on my exponent here, so that means I'm multiplying. My number is going to increase, and this is a very, very large number. So you can leave it as this on your multiple choice or on your guided practice or your independent practice, but just know that this number is very, very large, and it's being expressed in what is called scientific notation. Okay, so just about done. The very last one is we have the recursive formula, and I just think of this formula as one that's identifying the parts of the particular sequence. So A1 again is your very first term, and then R is your ratio. So we're going to write both formulas for the sequences that we see here. So for the very first one, we need to find the ratio, and the ratio is multiplying by 2. So for the explicit sequence, I'm going to say my very first term, so AN is equal to 1 times 2 to the n minus 1 power. For the recursive formula, I list the very first term, which is 1, place a semicolon, AN minus 1, and then my ratio is what I'm multiplying it by. Okay, for the next one, to find the explicit formula, which is used to find the term that it's going to end up asking for, I write down my first term, and now I need that ratio. So be careful, because it looks as if I'm dividing. Well, I am technically dividing by negative 2, but remember it's written as a ratio, so technically I'm dividing or multiplying, by negative 1/2. So make sure that you're very careful and you're writing it as if you're multiplying and not dividing. So we're going to say multiplying by negative 1/2 instead of dividing by 2. And then we have n minus 1 to find the nth term. The recursive formula just asks you to state the very first term, which was 16. There's a semicolon in there. N minus 1 times your ratio. Ooh, sorry y'all, I got too excited. I can minimize my screen over there. Okay, times your ratio, which in this case was negative 1/2. Okay, so I'm going to go ahead and erase this. You guys feel free to pause the video or rewind if you need to see this section again. And we're going to write both the particular formulas for this one again, because on the next screen it's going to ask you guys to find the term that there's going to be a term number for you to find. So here, I'm going from 25 to 75, I multiply by 3. 75 to 225, I multiply by 3. So my explicit formula states that I have the very first term, which is 25, times my ratio, and then n minus 1. My recursive formula is just asking me to identify the first term, which is 25, A sub n minus 1, and then my ratio was 3. On this one, I need to find my ratio, which happens to be 3 as well. And to find my explicit formula, I use the first term times the ratio, and then n minus 1 being my exponent. Recursive just asks me to state the first term, which is 3. There's a semicolon there. We have A n sub 1 times 3. Okay, so there was writing your explicit, there was writing your recursive, And I'm going to look at my notes. So I have the formulas written down as I switch to the next slide so we can find the terms that it is asking for. So on the very next slide, we're going to be using the same sequence, but it's asking for a particular term now. And again, my favorite is using the explicit formula because the recursive one gives you information and it's going to require you to know the term before the one that you're looking for. Recursive is. Explicit, we don't. We just plug it in as an exponent and we keep it moving. So I'm going to take 25. Remember, my ratio was 3 and 10 minus 1, which we know is 9. So I'm going to use decimals.com to take 25 times 3 raised to the 9th power. So go into decimals.com. 25 times 3 raised to the 9th power. My number is 492. Make sure. So 492,075. 492,075. 492,075. Yeah, there's no way that I would want to multiply by 10. Multiply by 3 10 times. So of course, like that's the workaround if you forget the exponential sequence or the geometric sequence exponential function. Here you can multiply by 3 10 times to find the 10th term. You're more than welcome to do that. But if you're taking the test and you remember the geometric sequence or the exponential function, I would definitely use that. So the next we need to find the 40th term. So we know to multiply by 3. And again, you can continue to multiply by 3. This is A1, this is the second term, A2, the third term, A3, the fourth term, A4, and you could keep on multiplying by 3 till you get to the 40th term. More than welcome to do that. However, I'm going to use my geometric sequence or my exponential function. So A1 is 3 times 3, and then n minus 1, and it's asking us for the 40th term. So that is 40 minus 1, which we know as 39. So 40 minus 1, so it would be 3 times 3 to the 39th power. So I'm going to go into decimals.com here. We are going to do 3 times 3 raised to the 39th power. And that one happens to be expressed in scientific notation. It's a positive exponent, so that means this number is very, very large. It's going to be increasing there in place values. So 1.21, I'm going to round that to 1.22 if you guys are okay with that. 1.22 times 10 to the 19th power. And I'm rounding it to 9.22 because my number right here was 5, which would kick that one up, round the one up to a 2. Okay, so if you guys have any questions, just remember that I am a private comment away on Google Classroom. Shoot me an email. And we are, again, working on geometric and exponential functions. And if you need those particular formulas, they are located on slide 5 of your lesson material for today. Best of luck on your